Well, good afternoon, and thanks for having me up here for just a few minutes. My name is Tim Amy, and I'm a sales engineer that works at Bromium. I initially thought this was going to be a karaoke competition, so I wasn't quite as prepared, but thankful to God it isn't, and you don't have to hear me sing. I'm going to just give you a brief overview of Bromium and who we are and what we're doing. So very quickly on the slide here, the thing I want you to take away from our slide about who we are, where we come from, is that two of our co-founders are the two co-founders of ZenSource. ZenSource being the hypervisor technology behind the vast majority of the cloud services like Amazon Web Services and LinkedIn and so forth, combined with our other co-founder who was a principal at Phoenix Technologies, a BIOS company. He's the guy that has sort of the idea to bring this all together. You saw yesterday, if you attended the conversation and presentation by Rahul about how to break sandboxes and what's wrong with sandbox technology. We've got some very sophisticated security people that have come over as well. And of course, then there's me. But anyway, the company is, we've been out with the product now since the fall of last year, and as you can see, we're not that old in terms of the company. But yet, we're doing some pretty impressive things. The thing I want to highlight as you look through these, I'm not going to read to you, but is the bottom one, just because this is a particularly interesting story. NSS Labs has a history, of course, I think we all have seen them do their tests for intrusion prevention and firewalls and a variety of different products. And the reason I point it out is they tested our product for endpoint security in the same way they test all the antivirus tools that they've tested. We're the first product in the history of this space and this testing to ever pass with 100% accuracy on every test that they did. When I get through this presentation, you'll understand that if we had done 99%, we would have failed because of how we're doing what we're doing. It's not about detection, it's not about how fast we can write signatures, it's not about DAT files. It is a completely different approach. And for our approach to be legit, we need to do 100% on every one of these types of tests. But we'll get back to that as we go. All right, so let's talk about what we're doing. Our core product is called vSentry, and vSentry's purpose is to eliminate the infections of malware on the endpoint. We do so by completely reversing the process of really what we've been doing for some time, which is the constant pursuit through the forms of signatures and heuristics and potentially even anomaly detection of detecting, or whitelisting and blacklisting, which are different forms of detection to a degree. The idea here is we're first starting off by tackling the key threat vectors that you see listed here. And we do so in a similar sense. When you first hear what we have to talk about, you say, oh, is that like sandboxing? You can imagine after yesterday's presentation, we really don't want you to think of us as sandboxing. Sandboxing in a layered approach is hardware, software, or operating system, sandbox, and then the applications in the sandbox. As Rahul pointed out, if you make calls to a vulnerable operating system, the sandbox does nothing to help you. Other tools might come in to try to detect the attack that's coming through. But again, as we've discussed, zero-day kernel exploit, sandbox is pointless. Further, the sandbox itself utilizes detection. Multiple applications run inside the sandbox. Applications until something detects it and says, oh, somebody did something in the sandbox, let's dump it. What we're doing is micro-virtualization. We're taking Zen, we're taking the brain trust of our co-founders, and we are taking its incredible architecture of multi-tenancy, like Amazon Cloud Web Services, and we're putting that on the endpoint. But instead of customer A and customer B and customer C being virtualized and kept apart from each other, we're doing it for tasks. Browser, tab A, doc, PDF, USB stick is in its own micro-virtual machine. And how this is distinguished from the sandbox? Well, remember applications, sandbox, operating system, hardware. It's hardware, microvisor, then operating system and applications. We are virtualizing the kernel. A kernel level exploit cannot get out of our micro-virtual machine. We are being able to enforce this through, we're going to get into it. I should be advancing my slides here. We're going to get in, the way we protect it, the way we enforce this is through the hardware. We're not relying exclusively on software and the behavior therein, but we're relying on the virtualization extensions within the Intel processors, as well as other processors, but today we focus largely on the Intel Core i3, i5, i7. Gives us the ability to do hardware-based virtualization on the endpoint. The hardware enforces the barriers, it also accelerates some of the things that we do, because the purpose here is for it to be seamless. When I demo it, I have to do all these things to make it unseamless so you can see what we're doing. But when we're actually implementing this, the purpose of it is that you browse the same way you browse. You open the docs the same way you open them. Word attachment in a resume sent into your HR folks, they open it and read it. But a weaponized PDF and a weaponized Word document or a website with a drive-by from Java or whatever it might be, all of them are occurring in micro-virtual machines. We're going to walk through how that looks. So here's our stack, our traditional operating system on hardware. We install our microvisor. We call it a microvisor largely because of where it sits in its footprint. It is essentially, for all intents and purposes, a hypervisor. Your traditional applications like your CRM or your ERP, it's going to run on your machine the same way it ran before. We're not going to virtualize that. But what we will virtualize is those key threat vectors I just highlighted on the other slide. So user tab A and B and C are each in an independent micro-virtual machine whose barriers are maintained by hardware, including the Word docs, the PDFs, the images, the movies, whatever else you're downloading. So let's go and examine one of these in particular. Because this particular one was to Facebook, it's got a Facebook cookie that's allowed to be there, and it has internet access. That makes a lot of sense. What it doesn't have access to is our intranet. It makes no sense for this one particular task that went to Facebook to be able to talk to my intranet, see my username, credentials, and information in Windows, be able to look at my registry and my file system. None of that makes sense. So it's not going to be able to do that. On the flip side, we have our PDF that we've opened. This PDF does not need access to the internet. Therefore, this micro-virtual machine will not have it. The policies that I'm describing to you are inherent. They're not to be configured and manipulated and have to build some big firewall list. It's obvious. It's the logical inference that if I have a Word doc open, I don't need that Word doc browsing the web. I'll use a browser to do that. But malware, on the other hand, might do a lot of other things. So those policies, which define what accesses or what resources are available and what access is available, again, they're inherent. There's a little bit of control you have. We're not trying to take the control away. Rather, there's only a few things you would ever want to be able to do here, like define whether they can copy and paste between them and define whether or not cookies persist. It's pretty simple stuff. But let's look at one in particular. So we have a micro VM. If you were to implement this in the traditional sense, that every virtual machine was a complete operating system stack, you would need a lot of RAM to enjoy our product. But what we do instead is utilize a technology, basically we call it copy on write. And the idea is you have this clean version of Windows. It's your image that you built, that you already have as your IT image that goes out on the desktop or the laptop. And that clean image is what we build as our virtualization model. Then every virtualized micro VM references that. It sees it as though it is the one only user of it. And of course, it sees it obfuscated based on those policies and rules. It doesn't see your file system, your IP stack. It sees a virtual copy that's totally different. You're hidden. But when it goes to make changes to those, as it's loading a web page, maybe it is in fact malware and it's attacking various things and making registry changes, those are the things we have to track in memory. So we're extremely efficient with memory. To each micro VM, they are the exclusive user of Windows on that computer. But in reality, of course, they are all sharing the parts that are redundant, and then they have their unique parts that we track. Then malware, getting into one of these, and a drive-by, bad news. But when we close the tab, it's gone. Auto-remediation of malware is extremely unsexy when you see it from the end user standpoint, because they never even knew it happened. They never saw the malware happen. They never saw any of the keylog or the Java drive-by. But on the flip side, the IT side, you get the picture of how exciting that is. The malware has nothing left behind. Nothing. We dive back in here a little bit deeper. Because there was only one task inside that micro VM, everything that it did is associated, everything we see, it's all attributable, 100% attribution to that one task. So figuring out what happened and being able to do a malware analysis is as easy as can be. So easy we actually automate it. So we have what we call live attack visualization and analysis. Because the malware had full execution, could do everything it wanted inside a micro VM that couldn't get out, couldn't touch the things it shouldn't touch, we can produce an event for you called a lava trace that walks you through how the Internet Explorer then launched Java and then basically dropped and executed file after file. We have command and control conversations, every IP address that it made contact with. Within the information that we have here, we also have registry changes. And then when you look at the files that were dropped, we get the MD5, the SHA-1. We can feed this data through standard format, through sticks, into a variety of different resources that you already have in your infrastructure to look for these threats, coordinate on these threats. So the use cases, I think, are pretty straightforward, but let's walk through them real quick. This is like wearing a big S when you go outside and you browse the web. It doesn't only happen when you're inside your infrastructure. When the endpoint goes to Starbucks, the S remains on you. This is a big key. Does this solve every problem in world peace and cure hunger? No, it doesn't. But it does mean you can browse the web without getting infected. Technically, you get infected all the time, but the infections have no value. You're bulletproof when you're browsing. That's a huge thing. It's also seamless so that your end users do not have the need to go and disable it or concern themselves with it. This is a big one. Remediation occurs every single time they close a browser tab or they stop reading a weaponized PDF that they never even knew was infected in the first place. I think this one makes a lot of sense. Patch for functionality rather than security. Do you have to run deprecated Java right now? God have mercy on you, right? But when you run deprecated Java in Bromium, there are no infections that occur. Nothing lasts, no fingerprints, no keyloggers, no kernel level access. You are protected. And then, of course, the part that most of us get excited about that the end user could care less about, the threat intelligence. You now have a proprietary security feed. Think about that. Proprietary meaning to you, your image, your users doing what they do, where they do it, when they do it, that's produced from all the malware that they touch that they never actually get infected from. Feed that into your SIM, feed that into your brain and trust and logic and understand how your people are getting attacked and targeted. Are we seeing just a massive number of weaponized PDFs in our recruitment and HR area? Or are we seeing contracts that are coming in this way? That's a sign that we have a problem that's maybe a layer 8 problem. We've got some human interaction. People are targeting us. It's not just random drive-by. That intelligence is yours, and it comes right out of your end users instead of buying a security threat feed that's about the globe. Those have value, don't get me wrong, but this is you. So the business outcomes from this, yeah, I think it's pretty straightforward. This allows you to focus your efforts in such different ways. You're no longer having to capture laptops and desktops to figure out where the malware did what it did and what it extracted. You know exactly what it did, and you know that it extracted absolutely nothing. That's the critical intelligence there. Well, we'll be out there the rest of the day if you have any questions to come by, but thank you very much for your time today. I really do appreciate it.